Hello everyone. So I am finally back again. Um, yeah, it took me some time. Uh, there were various reasons why I was a little caught up with different work and all. Anyways, we were doing the chapter of motion of class 9, isn't it? And we have done a substantial part of it. We have done the three equations of motion. We have tried to understand distance, displacement, speed, velocity, acceleration, etc. Now, we'll try to solve a few questions. These are the questions directly taken from the NCERT book. Fine. Some are from inside the chapter, some are examples, as you will see, and a couple of questions from the exercises. So, we'll try to understand how to solve these questions. Okay. So, let's start. Now, as you can see, the first question here says that Usha swims in a 90-meter long pool. So whenever you have to solve a problem, always write down what is given along with variables. So the length of the pool is given as 90 meter. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed. So let us say this depicts the swimming pool, which is 90-meter in length. She starts from here, she goes there and returns back in 1 minute. So the time taken is 1 minute. Remember, always convert your values into SI units. So the time taken is 1 minute, which is equal to 60 seconds. Now what we have to find out is the average speed and the average velocity of Usha. So let's start. So when we talk about speed average, how do we define it? Remember, total distance upon total time. Now it is already given that she covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. So she is covering 180 meter in 1 minute. So her average speed turns out to be 3 meters per second. Now, velocity average. Remember the equation for velocity average? It's total displacement upon total time. So the question is, what is the total displacement? Because the time is 60 seconds. Now, how do we talk about total displacement? Total displacement is the straight line distance or the straight line path length between the initial point and the final point. Now, the initial point is where Usha starts to swim from, and the final point is the same point where she reaches back. So, if this is the initial point and this is the final point, then the total displacement is 0 because she came back to the same position again. So 0 meter per second is the average velocity. So see the distance, the difference between average speed and average velocity. In average speed, we're talking about the total path length or the total distance. So 90 meter one way, 90 meter the other way gives you 180 meters. Total displacement is the distance between the initial and the final points. And because she came back to where she started from, the total displacement turned out to be 0, and hence the average velocity is 0. Fine. Now let us move on to our next question. So the next question says that a train is started from rest. So let's write down what is given. a train is starting from rest. So the initial speed given is 72 kilometers per hour. And I hope you know how to convert it to meter per second. We will be multiplying it by 5 upon 18. So how much does that become? It is 20 meters per second. So a train starts from rest. Oh, my bad. This is the final velocity. Attains a velocity of 72. So it is the final velocity. Because it starts from rest, so the initial velocity is 0. And it does it in 5 minutes. The time taken is 5 minutes. I hope you remember what is 5 minutes. We will convert it into SI units. So 5 multiplied by 60 gives us 300 seconds. Now we have to find out the acceleration. Now how are we going to find out the acceleration? We have got the initial velocity, the final velocity, and the time, which means we can use the first equation of motion, V equals U plus AT. If I rewrite this equation isolating A, I will get V minus U upon T. So what is the V? V is the final velocity, which is 20 meters per second. U is the initial velocity, which is 0, and time is 300 seconds. So we get 20 upon 300 or 1 upon 15 meter per second square. Pretty low acceleration. Anyways, so the acceleration turns out to be 1 upon 15 meter per second square. Now the second one is the distance traveled by the train for attaining this velocity. So we need to find out S. How are we going to find it out? We can find it out using two different methods. The first method is we can use the second equation of motion, which says S equals ut plus half AT square. So initial velocity is 0 multiplied by t, which is 300 seconds, plus half into a, we just found out acceleration, which is 1 upon 15 multiplied by t square, which is 300 times 300. So 15, 20, 2, 10, the distance turns out to be 3000 meter or 3 kilometers. The second method is by using the third equation of motion, which is v square is equal to u square plus 2as. How do we do that? We use s, which is v square minus u square upon 2a. So what is the v, which is the final velocity? That's 20 square minus u. U is 0, so that's 0 square upon 2 into a. 2 into a, which is 1 upon 15. So what do we get? We get 20 into 20 into 15 divided by 2. So 2, 10. 200 multiplied by 15 turns out to be 3000 meter. So you can do this question, especially the second part of the question, in two different ways. Because you know V, U and T is already given. So you have figured out the A. So you can use the second equation of motion and you can use the third equation of motion. Either ways you will get the same answer, which is 300 meters. Now, moving on to the next question. It says, a train is traveling at a speed of 90 kilometers per hour, which means because the train is already traveling, hence, when we talk about what is given, the initial velocity is given, which is 90 kilometers per hour. So 90 into 5 upon 18 gives us 25 meters per second. Fine. So we just converted kilometers per hour to meter per second. Then it says brakes are applied as to produce a uniform acceleration. So now an acceleration of minus 0.5 meter per second square. Minus, here the minus means we have a retardation, because the speed will be going down as the brakes have been applied. Find how far from the train will go before it is brought to rest. Remember, the word here is brought to rest. That means the final velocity will be 0, and how far, so the displacement has to be figured out. So we have U, A, V and S. So what are we going to use? The third equation of motion, which says V square equals U square plus 2AS. So S is equal to V square minus U square upon 2A. So what is V? V is the final velocity, so that's 0. Initial velocity is 25, so that's 25 square upon minus 2 times A, which is 0.5. Now 2 times 0.5 gives you 1. So it is minus 25 square upon minus 1, and that should be 625 meters. You see what is happening here? Why did we put the minus sign here? That is because the acceleration given here is minus, which means the train is retarding, and that is why it will come to a stop. So always keep in mind, when you read the question, read it properly, so that you understand what has been asked. Okay? Now, moving on to the final question for the day, we have Abdul, while driving to school, computes the average speed for the trip. So the V average is 20 kilometers per hour. On his return trip along the same route, there is less traffic and the average speed, so we have got two average speeds. So let's call it V average 1 and V average 2. And 2 is 30 kilometers per hour. We have to find out the actual average velocity. Now, this is an interesting question. Why? Because only average velocity is available, and you have to find out another average velocity. Now, some of you might be tempted to say that average velocity would be very simple. We just say it is V1 plus V2 divided by 2, so that comes out to be 20 plus 30 divided by 2, and that is 25 meters per second. That would not be correct, because you cannot really add the average velocities and just divide them by 2. So this method, if you are going to apply this method, this is a wrong method. So what are you going to do? We are going to start with the equation of average velocity, which is total displacement. Oh, we have been asked average speed. So never mind, we will use the same equation. Only that instead of total displacement, we will be using total distance. Total distance upon total time. But the question is, how do we find out distance? Well, let's assume it. So we are going to assume a little bit of a distance. Fine. So let us say Abdul starts from this point, goes straight to this point. So there is a distance called x. So during his first trip, the time taken by him was x upon 20, because he went at 20 kilometers per hour. So the time taken must have been distance upon 20. In the second case, when he is returning, he has a different time, because now he returns at a much faster faster speed, so that is x upon 30. Fine. Now remember, the average speed in this case is total distance. So what is the distance? He goes x distance, he comes back x distance. So what is the total distance? It is 2x. X plus x for going, x for coming. And what is the total time? The total time will be the time taken to go in one direction plus the time taken to go in the other direction. Fine. So now let us put all these values together and see the total distance is 2x and the total time taken is x upon 20 plus x upon 30. That's a matter of simple calculations here, and we have 30x plus 20x. I usually do not take LCM for small values which can be calculated easily. Plus 20 is 50x. So x goes here, and we have 0 going there. 5, 12, 12 into 2 is 24. So the average speed turns out to be 24 meters per second. If you remember what we were getting using that equation, it was 25 meters per second. And that would have been wrong. That would have been utterly wrong. So the correct method is, when you get a question like this, start with the fundamental equation, the governing equation, which in this case is total distance upon total time. Then try to find out the distance. If the distance is not provided, assume it. Assume the distance. So we have assumed the distance to be x. And then we continue further. Fine. So that would be it for today. I've given you 4 different questions to deal with. Fine. And I've shown you how to solve these kind of questions. I hope you understand it. Good. So next, we will meet again in the next video, and we will be talking about circular motion. Okay. Till then, bye from my side.